So, indexes in SQL Server. Long story short, it's a structured way of retrieving your data nice and quickly. It's similar to an index in a book. If you get to a book, you want a particular chapter, you want a particular subject, you go to the index, find where it is, and you can get to that information faster, rather than having to look through the entire book to find what you need. Indexes, they store a subset of your data. If they're a non-clustered index, most indexes store part of your data, not all of it. The only exception to that is clustered indexes, which we'll cover in a second. It's worth noting, when I talk about indexes and I talk about hardware requirements and the physical requirements of an index, which is storage, reading from disk, storing in memory, all indexes, if they're used by SQL Server to read data from, will be stored in memory when it needs to read the data. One of the things we'll talk about is being as strict as possible as you can be with your indexes. The reason for that is you've only got so much memory on a server. You can't load multiple copies, or most people can't load multiple copies of their entire database into memory and store it there. It's just not viable. So we'll go through understanding how that works, how it gets pulled into memory, how it gets stored, and why we need to be careful with what we're doing. As I mentioned, there are a few different types of indexes, and we'll go through them in the next list. In the next few slides. But we basically come down to clustered and non-clustered indexes. That's the primary two indexes you'll see out there. The other ones are subsets of or specialist use cases, and we'll go through those. So, what is a clustered index? You've got two options when creating a table. You can create it with a clustered index, or you can create it without one. It's a binary choice, one or the other. If you don't create a clustered index, it's what we call a heap table. Now, what that means is the data is stored on disk however SQL Server wants to. If you insert some data into that table, you'll ask SQL Server to store it, and SQL will go, okay, I'll find the next available space on disk, put it there. It doesn't matter where that is. What that means is it's nice and fast. You could throw data into a heap table. The problem you'll have is when you come to retrieve that data, you ask SQL Server, I want some data for this table. It doesn't know what data you want necessarily. It doesn't know where that data is. It returns the whole table, but it also does that from all over your disk. Those of you who are old like me will remember disk defragmentation that we used to have to do in Windows XP. It's basically that. It will be stored all over the disk. What a clustered index does, if you create a table with a clustered index, is you create a clustering key. Now, that could be a primary key, it could be a non-unique key, and we'll cover those in a minute. But basically what you do is you say, I want to store this data sorted on this field or multiple fields. And that fundamentally changes how the data is stored on disk. And SQL Server will, when the heap's rebuilt or when it's created, the clustered index is rebuilt or when it's created, SQL Server will take all the data, it'll sort it based upon your clustering key, and it'll store it all neatly together on disk. The advantage of that is when you want to come and read the data, we'll be using some examples. There's the Stack Overflow database later on, which is the database that sits behind stackoverflow.com, the question and answer website. If I go to the users table and want information on Rich Benner, and I've indexed it on Rich Benner, what will happen is instead of having to give me the whole table and go, well, here's the whole table, find the bits you want, it can go, okay, I know exactly where the R's are and probably the Riches are and the Benners, and it could just return me the data that I need. So that instead of returning millions of rows of data, it returns a handful. There's not many Rich Benners in the world, especially on the Stack Overflow database. I think there's 6 rows of data that get returned. And we'll go through some examples. But just to visualize what that looks like, data on the left here, this is effectively stored without a clustered index. So on the left is a heap table. It's stored on disk randomly. There's no sorted order. So imagine looking through that for display name Rich Benner. It's going to be tough. You'll have to scan the entire table, which is slow. On the right, you can see this is the same table, but with a clustered index on display name. And you can see it's sorted in display name order. And behind the scenes, some statistics will get created, and we'll talk about that in a second. But basically, if I'm looking for the R's, it's alphabetical. I know I can ask SQL Server, and it knows where the R's are, and it'll just return the data a lot faster. The downside of a clustered index, and it is the strength of a heap, is when you're inserting data in, For a heap, it just goes in. For a clustered index, if I'm inserting a new user, if I create a new username of Rich Benner with a different account ID, it has to find where I go in the table. It goes down to the particular data page where the data is stored, and it inserts a new row into there. If that data page is already full, it will cause a page split. And we'll cover this again in a minute. But basically, you have to search the data, find the right place, insert it, do some page splits maybe. It's more work to insert. Nowadays, on modern hardware, it's not so much of a problem. It used to be a big deal. But it's more work to insert into, but with greater benefits of reading the data. So it's a balancing act. There are some use cases where you definitely go with a heap table. If you're throwing a lot of data into the table, and by a lot, I mean hundreds of thousands of records a minute, you go with a heap. But you'd be aware that if you're trying to read that data from the table, you're not going to have a good time with it. That's clustered indexes versus heaps. But what you can also do on the table is create non-clustered indexes. Now, these don't change the structure that your data is stored on disk. You can create a non-clustered index on a heap table if you want. But what this does is you create an index on a field that you're using in your queries. So in the previous example, display name. I might index display name. If I'm constantly looking up people's reputation, for example, based upon their name, I could create a non-clustered index on the display name field and have an included field which will return their reputation. Now, it's worth separating those two fields because it's those two groups of columns. You can have indexed fields, which could be one, which could be many, and that's the order in which your data is stored in this index. You can then have included columns, which are just along for the ride. So you're not searching using them, but you do want to return them as part of your query. You can do that. So in this example, and we'll go to an example. At the top here, this is my query. I'm looking for a guy called John Skeet. He's got the highest reputation on Stack Overflow. I'm searching, my predicate is on display name equals John Skeet. And I'm returning display name, but I'm also returning reputation. Now, if there was no index on the table, which helped me here, you can see on the left, it takes 208 milliseconds to do that query. And bearing in mind, this is on my laptop here, which has an M2 drive, which is directly attached. If you're on in the cloud or if you're on any sort of array, it'll take longer. This is the fastest you'll see within reason. So it takes 208 milliseconds and it does 86,000 reads. Now, what a read is, and please ignore logical versus, you'll see physical sometimes as well. What a read is fundamentally SQL Server stores data in pages that are 8K large. You'll never see that as a user unless you go crazy with a hex editor and look at and dig into the data files. But that's how it stores data in pages with 8,000 bytes. Each one of these reads is a page. So what we're saying here was we're reading 86,000 pages from disk. And what that means is we have to read that off disk, we have to bring it through the network, and we have to store all that in memory in order to do this operation. On the right here, I created an index, which is on display name and includes reputation. It completes immediately, and it does 3 logical reads. Now, the way you can see how many logical reads you're doing is at the bottom there. On your query, for the first line in your transaction, you could put set statistics time IO on, and then run your query. And that'll give you a lot of useful statistics, including these. It'll output into the message tab in Management Studio. If you're ever curious what tables a query is reading, how many pages it's reading from those, how long it's actually taking, then set your statistics on and get your messages tab. If you're having problems reading the stats because there's a lot of information, then copy that and paste it into statisticsparser.com. It's a tool created by Richie Rump, which formats it nicely for you. You can see for each table how many reads you're doing. There's so much more information in there. That's a whole webinar in itself. But that's where I'm getting this information from the set statistics on. These 2 queries I ran them side by side, by the way, which is why on the query 1 you can see 100% of the cost for these 2 queries was query 1. 0 of it was from query 2. It's just much more efficient to read the data this way. And you can absolutely apply this in your own environment, similar queries.